1 year ago, I posted my first video here on YouTube showcasing how to build a REST API with Kotlin and Spring. Today, I am celebrating my 1-year anniversary by recreating that video, but with some slight adjustments. We'll still use Kotlin as the programming language, of course, but when it comes to web frameworks, I'm switching from Spring to Ktor for reasons which will become obvious in the next few minutes. If you are new to this channel, welcome. I'm a software developer with close to 15 years of experience. During this time, I worked with various tech stacks from the web dev world. My background is mostly in Java, but these days I spend most of my time in the JavaScript ecosystem. However, at times I still need to build proper, scalable, grown-up backend services, and despite the advancements in the Node and Deno spaces, there is no denying the Java environment is still one of the best ones to build great backend software. The good news for you is that the Java space changed a lot in the recent years, and it is now more fun than ever to use Java-based programming languages and tools. Okay, enough with the talk. Let's get into building this API. To get the obvious out of the way, we'll write our code in Kotlin. If you are not familiar with it, Kotlin is a multi-platform, object-oriented, functional programming language. It is targeting the Java virtual machine and can interpolate fully with Java. Fun fact though, it can also be compiled into JavaScript. Its features made Kotlin become one of the fastest growing languages in 2022, and Google made it the preferred language to build native Android apps back in 2019. The team behind Kotlin is JetBrains, the same guys who are developing the popular IntelliJ IDE. On top of that, their application framework Ktor is rapidly growing in popularity, and it is becoming a real alternative to established solutions such as Spring Boot. We can easily start a new Ktor service from their online project generator page. We'll define a name and some basic settings. Next, Ktor's features can be extended via a plugin system, and in this second step, we'll add a routing plugin to map and handle HTTP requests, the exposed ORM to interact with the database, status pages to handle errors in a unified way, and a default headers plugin to auto-add some useful headers to our HTTP responses. You'll see that some of these added plugins have implicit dependencies, which will be added to your list as well. Next, you can download the project and load it up in your favorite IDE. I'm a big fan of VS Code, but for Kotlin work, I'm usually using IntelliJ. So let's take a quick look at the project structure. Gradle is the build tool in charge of managing our dependencies and compiling our files. We'll make some small updates in the build.gradle file when we'll add new libraries in the project, but other than that, you don't have to worry about this too much. We'll do most of our work in the source, main Kotlin directory, and we'll use the application YAML file to define various properties needed in our app. All Kotlin projects start by executing a main function. We can define this in the application.kotlin file. Ktor allows you to use modules to structure your application by defining a specific set of routes inside each module. In our case, since we are building a basic API with only one entity, we'll create a single module. In here, we'll install the plugins we added as dependencies in the setup phase. This process is more than straightforward for most cases, so we'll simply add the default headers, the content negotiation, and the status pages plugins with some basic implementation details. For instance, whenever an exception is being thrown inside our module, this will be caught by the status pages plugin, and the 500 response with some error details will be sent to the client. Then, we'll initialize our database connection and the data access objects. Finally, we'll install the routing plugin and we'll register our task route listeners. Don't worry, we'll implement all this in a second, but first we need to set up our database. In other tutorials, I either used an in-memory database solution or SQLite, but for this one, let's do things the proper way. We'll persist our data in Postgres and we'll use Docker containers to manage the database instance. In a Docker Compose file, we'll define our database service using a Postgres image and some basic configuration details. Then, using the Docker Compose app command, we'll start our container at this port. With the database running, let's quickly jump into our application properties file and define the database credentials we'll use to connect to Postgres. These config files can contain both custom properties and default property names like the server port or the main modules. Then, we'll use all this to create our database connection in Kotlin. We are in the Java world, and the theory says you should have at least one file called factory in a Java project. Therefore, in a database factory file, we'll initialize our database connection using the config properties defined earlier. You are also in the big leagues now. In the real backend world, scalable performance services rely on connection pools to efficiently manage their database interactions and on multi-threaded programming to efficiently handle workloads. So we'll configure a Hikari connection pool, which will maintain and reuse 3 active connections to Postgres. We'll also define a suspended query function to leverage Kotlin's coroutines and avoid blocking threads while waiting for database responses. We'll use this function to wrap all our database queries. As you probably know, working with the database is one of the most time-consuming actions in web development, and different programming languages employ different strategies to avoid locking resources while waiting for database responses. Okay, finally, when the database connection is initialized, we'll open a transaction and ensure our tasks table is created. We are doing this using the exposed ORM, so let's jump into the models directory and create a task.kotlin file to see the implementation details. First, we'll define a tasks object which extends the exposed table class. In here we can define object properties which will be then auto-mapped to database tables. This code should be pretty self-explanatory. In short, we are defining some common column types for our properties and an auto-increment primary key. Then, let's create a task data class which can be mapped to the database table entries, and, as a best practice, a data transfer object we'll use to exchange task data between our API and the client. Note that both our classes are serializable, so that our content negotiation plugin knows it can work with these entities. Now, for the fun part, we'll define a task data access object file where we'll write the usual create, read, update, and delete database operations. First of all, exposed returns result row objects, so we'll create a simple function that allows us to convert the result row into a task object. Then, using exposed utility methods, we can easily perform the usual operations. If you are coming from a Spring plus Hibernate background, this might seem like a little bit more work, but all in all, I believe Exposed and Ktor are doing a decent job in providing a good developer experience. This is also a good time to address the elephant in the room. Spring still rules the JavaScript ecosystem, but its reflection-based model leads to slow start times, larger memory footprints, and suboptimal resource utilization. On top of that, pairing Spring and Hibernate with Kotlin has its pitfalls, especially since Hibernate doesn't work well with Kotlin's immutability architecture. So, even though the Spring ecosystem is huge in all regards, it is important to know that there are real, more modern alternatives out there which can perform better and are more suited for the type of services and deployments we are doing these days. Before moving forward to defining the routes of our API, I'd like to take a second and ask you to help me fight the YouTube algorithm by liking this video and subscribing to the channel. Okay, in a taskroutes.kotlin file, we'll define a general route mapping the /API/task-based path and a bunch of functions mapping the usual HTTP verbs you use in REST APIs. There are a couple of things of interest here. First of all, inside these functions, we can use the available call object to easily extract path variables and perform basic type validations if needed. Of course, you should always properly validate any type of user input. Second of all, most of the mapper functions are linked to the data access object methods we defined a bit earlier. Depending on those responses, using the same available call object, we can send appropriate HTTP responses back to the client. Finally, the call object also provides a receive method which can deserialize response bodies into Kotlin objects. I am using the DTO object in such instances because all its fields are marked optional and, therefore, the client is not forced to send the full object for patch actions. This gives me the chance to mention one of the many interesting aspects of Kotlin development: opting in when using experimental features. Since the client might not send complete objects to the server, we need to force our JSON converter to allow null values. This is, however, still experimental, so you need to mark your module accordingly. This is great development behavior, which leads to less errors and more predictability in your code. Let me know in the comments what your opinion is about Ktor and if you are interested in more material on this subject. For instance, Ktor can be a good alternative to the likes of Astro in building multi-page architectures and can be easily combined with Alpine.js in such scenarios. Also, if you are interested, down in the description you can find the first video I ever posted on this channel, where I'm doing a pretty bad job explaining the basics of Spring and Kotlin. Until next time, thank you for watching.